if you live in an arid region or you don't have a whole lot of water to play with to begin with, that you can get rid of your nitrogenous waste without investing a lot of water. Okay? Amount of water required for excretion is very low because it's this paste. Okay? All right. Now, the osmoregulation and excretion are going to come together now, where we talk about excretory systems. We're going to start to put together this osmoregulatory function and the excretion function, and at times they're hard to tell apart. The excretion relates to the nitrogenous waste. The osmoregulation is the salt balancing, water balancing part. Okay? Now, we're going to talk about a few different kinds of excretory systems. Again, I want to start basic and build our way up to the vertebrate kidney, which is insanely complex. Right? We're just going to start its complexity in AFF. They'll keep going in human phys. And those of you that are moving on, they'll get more and more complex as you move on. But I want to ease our way into that by starting with some basic stuff. And the basic stuff to mention here is that any excretory system, I don't care what organism you're talking about, there are basic design elements. So let's do that. Excretory system design elements that are always present no matter what excretory system you're talking about. These elements are the basic foundational material, and then we're going to kind of complicate it by making these pieces a little more complex. But all of them have these same pieces. The first piece is called filtration. Now, what filtration is you take fluid from the body and you filter it. So you run it through some kind of a sieve, right? Something that allows small stuff to get through and big stuff can't. So this process right here is filtration. I have a fluid here and the small stuff leaks through down to here. This stuff we'll call fluid. Could be interstitial fluid in some organisms, it could be blood in others, or hemolymph. And then down here, the material that got through my filter, I'm going to call filtrate. So filtration produces filtrate. The filtrate is all the stuff that was small enough to get through the sieve. Okay? All right, the second piece is reabsorption. Okay? Now, all of the stuff that got through because it was small. Well, there's some small stuff I might want to keep. Calcium ions are pretty small. Well, maybe I'd like to have some of those back. Glucose is pretty small. Maybe I'd like to have that back. So the reabsorption step is basically to take stuff from the filtrate and pull it back into the fluid. I'm reabsorbing things. I'm moving things out of the filtrate and into the fluid. Out of filtrate and into fluid. That in a nutshell is reabsorption. On our diagram here, the first step was filtration. This step here is reabsorption. This is fluid. In that case, it would be the serum within the circulatory system. And that makes this material in here filtrate. Okay? Notice also, I didn't mention this, but I'll mention it now. In these systems, you typically have an epithelial layer that separates the fluid from the filtrate. So here's my filter. It's these tiny holes in this fenestrated capillary. Material comes out of it if it's small enough, but I still have this step here that requires an epithelial layer that's doing the movement across the epithelial layer into the filtrate. And then for reabsorption, I'm using the epithelial layer to move things from the filtrate to the fluid. Third step is called secretion. a note here.